Good evening, everyone. We welcome you this evening for the 50th Computer Engineering Seminar, Research Paradigms in Network Security and Cryptography, organized by ASUS, the Association of Computer Engineering Students. Today's session will comprise the following topics: the importance of network security and cryptography, the open issues and challenges in these areas, and also research areas that can be explored in network security and cryptography as well. Finally, we would love to have an open discussion with the audience regarding today's session. Let me introduce our resource person for today's session, Dr. Deepak Prasad. He is working as an associate professor and head school in the computer science department at Lovely Professional University, Punjab, India. Further, he has published more than 80 research papers in reputed national, international conferences and journals, and also one of the editorial board members of recognized journals and serving as an technical program committee member in reputed international conferences in India and abroad. Moreover, he is a certified network engineer from CompTIA, USA. Without much ado, let us begin today's talk. Meanwhile, if you do have questions for our speaker, you may raise them at the Q&A session in the end. We will be sharing a Padlet link during the seminar for questioning. Also, you can use the chat section in Zoom as well. With that, now I hand the session over to Dr. Prasad to deliver the research paradigms of network security and cryptography.
Good evening to one and all present over here in Sri Lanka. Very good evening from my and from India. So thanks, Hassan, for such a wonderful introduction of me. So I hope my voice is audible, Hassan. It is okay. Can we start?
Yes, sir. You're audible.
Okay, thank you. Thank you so much. Thank you. So I hope that everyone is safe and sound and they are native place right now. So as Hassan told me, everyone that I'm Dr. Deepak Prasad, the hand of School of Computer Science and Engineering in lovely University, Punjab, in India. So I'm working in this particular field of network security, cyber security, blockchain for the last, I would say, for the 7-8 years. And moreover, I am closely working with my research team in the particular area of image processing, machine learning, data science, specifically in the security field. So this particular presentation which I'm going to share with you is related to network security and cryptography. So the major theme what we're going to cover today is about the importance of network security and cryptography. You all might be aware about network security. You might have heard of some network security, cryptography, but it is much beyond that. So we are going to explore that what could be the other thing which makes network security so much popular in that current scenario, and how we can effectively utilize in our daily communication or daily routine work. The second thing what we're going to stress upon is about the issues and the challenges, because once there is technology, there is definitely some challenges would also be there. Because with the advancement of the technology, there are so many prominent attacks which are happening, so many challenges, security flaws which are there in the existing system, or so many vulnerabilities are there in the current system. So that needs to be taken care of. So simultaneously, we will talk about the challenges, the issues which are there in the current network paradigms or in the cryptography side, and how to overcome those things. And the last but not the least, that will be what is the future instead, what we need to do in the future. What are the open possibilities where you can collaborate, you can research, and you can get some test results, either in the form of algorithm, either in the form of deployment of some services which are very much secure. What could be your approach? So that will be the last part of my presentation. So I'm going to share my presentation. Give me 1 second. I hope, Hassan, it is viewed to everyone. Can you see this one?
We can see your presentation, sir.
Thank you so much. So I'm going to start from this one. So as you all know, I am from School of Computer Science and Engineering from lovely Professional University, one of the largest university in India, with more than 35,000 students in campus, in a single campus over here. So let's start with the today agenda of my presentation. So my agenda for the presentation would be like the first we going to talk about importance of network security and cryptography. The second thing we move towards the open issues and the challenges in network security and cryptography. So we're going to talk about the challenges. It is not, I'm going to take some scenarios like I'm going to talk about, because network is a very wide thing. When we talk about network, it is not only a simple network. We talk about, sometimes we talk about as wireless sensor network. You might have heard of this thing. It could be a mobile ad hoc network, a MANET. It could be VANET, regular ad hoc network. It can be PANET, like drone. Nowadays, very common thing is UAV, unmanned area vehicles. So network security, network is a very vast. So when we talk about a network, definitely there are some challenges in the network. So we're going to explore those challenges, what are the issues and the challenges which are still persistent in the network, and how we can overcome those challenges, what security measures we have to adopt, and what about the cryptographic techniques we can adopt. And last but not the least is the research area where we can work upon, or which are still open for you to work further as a part of your project, as a part of your PhD, as a part of your master's in the time to come. So when we talk about the importance,
we can't really see your presentation. What we can see is PowerPoint as the first slide.
you're not going to see my presentation now. I am just scrolling down.
No.
Now it's clear. I think I'm the third slide.
I think you are sharing the wrong screen. Like we can see your slides, but not the moving one.
Let me do one thing. Now I think the slides are not moving, sir. Let me then do it again.
Not yet. Maybe you can remove and share. Okay.
Let me stop sharing and share it again. It is more effective. Let me know when I am going to share it again. Now it is visible, sir. Now it is okay.
Still, sir, we can see the PowerPoint application, and the slideshow didn't show in the screen.
You're able to see my this one slide importance one CIA trade or not?
We can now see the CIA triad slide.
Yeah, yes. Now you can see the terminology slide.
Sorry, sir.
Can you see the next slide also? I'm just scrolling down. Are you able to see or not?
No, sir.
Yes, I'm sure. Just wait. Stop sharing. Let me know. Just Hassan, could you tell me right now whether you're able to see my screen now if I'm moving it?
Yeah, we can see the PowerPoint application, and you are currently in the fourth slide, CIA triad.
Yeah. Now it is okay. Can we start now?
Yes, we can see the agenda slide now.
Now I'm moving toward the next slide. It is okay now?
Did you move into the next slide? But we can see still the agenda part.
I move to the next slide. From this point?
Yes, please. Thank you.
Okay, thank you. So I was talking about the first thing is about the importance of network security and cryptography. Like when we talk about, we all are using the network, we are all using the computers, and no one of the tasks cannot be completed without a system. Every one of us are using mobile phones or laptops or PTAs in our day-to-day communication. So whenever we are using the systems or computers or the digital devices for our business purpose, for our education purpose, for our own professional purpose, or our own normal routine, we are always susceptible to some attack, because most of the time, we are not aware that we are under a particular threat, or our system will be compromised, or there is a possibility of a breach in our system or our network. So whenever we talk about the network, we are talking about the devices. So device security is the most important. So how we can secure the devices? It could be a physical security or some other ways also, but the security of the device is a prominent. And we know that the multiple number of devices are constituting the network. Okay, if you take any application, if you talk about a WhatsApp application or Facebook application, so basically a network is a collection of devices. And whenever a device is a part of the network, then one important thing is that we have to secure the network side. But how to secure the network? How to secure the communication which is moving through a network? So that is the most important thing, and that we need to explore. So guys, when we talk about the network security, there are three things on which this whole scenario or the whole mechanism depends. What we call CIA trade. So CIA means is basically, we can say, it's basically a model of deployment. It's a model of deployment for creating a secure system. Whenever we want to create some secure system, we want to apply this CIA trade. Most of the business organizations, whenever they are making some secure solutions or they are making the application, they want to ensure that whether they are following the CIA trade or not. So what is CIA trade or CIA trade? It is basically consists of two things. C stands for confidentiality, I stand for integrity, and A stands for availability. So if I talk about confidentiality, means whatever is being communicated between the two devices or between the two entities, that should be secure. That should be in a confidential manner. No third party can get that information. So confidentiality is that. But how this confidentiality can be met? How we can get this confidentiality? It can only be there that whatever is being communicated, it should be communicated in a secure manner. So there is a need of some techniques, there is a need of some approaches which are required for confidentiality. And here comes the role of your encryption techniques or cryptographic techniques or various algorithms which could provide confidentiality. The second thing, which is very important, is about the integrity. Like if I send some data to someone and some hacker is there or some attacker is there, and he can change the data. So what it means that whatever I'm going to communicate is not the same thing which is being received by the another person. I'm sending something different, and the person who is receiving it is getting something different. So that thing is basically a breach of integrity. Integrity means the state of the information would be static. Whatever the state of the information is there before sending, the same state would be there after sending or during the receiving of the data by the receiver. So that is the integrity. And if we talk about the integrity, we talk about different techniques. I'm going to share you the different techniques for integrity. These are just the basic things, because once we move to the cryptography, we must know about the basics. So integrity can be maintained with help of some techniques like hashing. You might have heard about hashing, but hashing is one of the way by which we can maintain the integrity. Some hash algorithms are there. So hashing is simply a simple concept of checking the integrity. We use some hash functions at the sender side on the data, and we get some hash value. And when we send the data to the receiver, we send again along with the data, we send the hash value. And the receiver is going to calculate the hash again on the data, what it received from the sender. And if both the hashes, the hash value which is generated at the receiver end is the same, it matches with the hash value which is being sent by the sender to the receiver that was generated at the sender end. If both the hashes are matched, then the data would be accepted. So this is a simple logic which is used for hashing to verify that whether the data is being tampered or not. But if the data is not being tampered, it means integrity is being maintained. But last but not the least is the availability. Even though we have the confidentiality. We want that whatever we are communicating among the devices, the information is secure. it is integrated, the integrity is maintained. But if the user is not able to use the services, is not able to access the system, is not able to access the server, is not able to access the applications at 24/7, then that is of no use. So here comes the concept of availability. And how we can get the availability? We should have some backup. We should have some ways by which if my system is not working or my network is not working, still I can be able to communicate. So there is a need of some backups, or we can say need some technologies which can avoid some failure to some extent. So when we talk about any organization, whether we talk about any organization, we talk about any industry or any education, anything you can talk about. Whenever you talk about the security of your system or your application, we need CIE. That any application, any system that have confidentiality, integrity, and availability, all the three things, all the three factors, one at a time, so that will be treated as a secure one. Because if one of the things is not being met, definitely there is a breach or there is a chance of being compromised. So that's why this CIA triad is a very important concept in network security and cryptography that we should know. Now, when I talk about some terminologies which would be very important for the cryptography to understand. So cryptography is basically the science, the art of encryption. Means we have some text, we have some data, we have some information that is called plain text, and we want to apply some algorithm, some key. And once we apply the algorithm or a key, it's converted to some other format, what we call ciphertext. And at the receiver end, the receiver must also need the key. Then only they can apply that algorithm and the key to get the plain text. So cryptography is basically the science of encryption. Now, if there is a cryptography, which is as a person, I have to encrypt my data. You know that I told you in the beginning of my presentation, when I start my presentation, that there's always a chance of being compromised because attackers are more clever. And if I need to make some good algorithm, I have to be one step ahead of the attacker. So attackers, how the attackers do? They apply some attacks, they apply some ways by which they want to compromise the system. They want to get some information from that ciphertext, because ciphertext is not readable. It is in different format. But they know that they will try to find out what is the meaning. They want to know the original message. So how they are doing this thing? So they are using the technology or the way that is called cryptanalysis, that they want to break the encryption. So they can use any type of attack. They can use some brute force attack where they can try all permutation and combination. They can use some dictionary attack, which is normally used by attackers in cyber security in compromising your password. They use rainbow attack for breaking the passwords of your system. So there's so many number of things which can be done by attackers, but cryptanalysis is basically the art of breaking of the encryption. Okay, but definitely cryptanalysis is in a different way. So when we talk about cryptology, it's a combination of cryptography plus cryptanalysis. So one thing which is very important, whenever we devise the algorithm, we can devise some cryptographic algorithm, we need to ensure that our cryptographic algorithm should be strongest one. They should be robust so that they cannot be easily compromised. They cannot be easily, the attacker cannot do the cryptanalysis of those algorithms very easily. So that is the most important thing while designing the cryptographic algorithm. But again, one challenge would be very important. Now, second thing, what we need to understand, once we design the cryptographic algorithm for any application, that is also very important. Like if I'm designing the algorithm for Bluetooth, then my requirement will be totally different, because we know the Bluetooth is a low energy device. If I'm designing some encryption algorithm for 6G, you know, we are moving toward the 6th generation computer, 6G technology, 6G, 5G, 6G. So again, the requirement will be totally different. It depends upon the application, the nature of application, the deployment area. These all things will be considered while designing the algorithm. So complexity of the algorithm is also taken to be into account while you are creating a cryptographic approach. So there were so many algorithms were there. You might have heard of so many algorithms which are used in cryptography. Let's take a simple example. Like many of us are using wireless communication. Many of us are using Wi-Fi, or we are using a hotspot on our mobile phone. But very few of us knows about that what cryptography algorithm which are used, what security algorithm or security approach is used in wireless security. So the approach is used is WP, wireless protected access. Earlier, one of the algorithms, one of the approach was WEP, that is wide equivalent private. But for the last 10 years, most of that wireless communication, we are using WPA2. But in 2018 also, this WPA2 was compromised. This was being compromised. One attack was called crack, key reinstallation attack. And even the person who has compromised this approach, he has published one paper, research paper, that how he has compromised this. So, but I'm telling you this thing why? So, because nothing is secure. If I talk about, and wireless is also not secure as it is. There are some flaws in every system. There are some vulnerabilities in every system that need to be taken care. But once we are designing the algorithm, we have to make sure that it can capable of mitigating the most possible attack which could be there on our network, on our application. So when I talk about a cryptography in a general sense, cryptography is categorized into two things: symmetric cryptography and asymmetric cryptography. I'm not going to discuss right now in more details about this thing, but we should know that in which areas we have to focus in the future or in research. So in symmetric cryptography, we use the same key, because I told you key is the main thing which is used in cryptography. We have the plain text, we have some information, and we have to apply some algorithm, and then we have to convert that plain text into cipher. So when I talk about the symmetric key cryptography, the same key is used for encryption and the same key is used for decryption. Means the same key. The key which is used for encryption is the same key which is used for decryption. You can take a simple example: a lock. When you put a lock to a key, so same used for locking and same key used for unlock. So that is a symmetric cryptography. But the challenge is that if that key is being given to someone else, so they can open the lock on your behalf. That is the main challenge in symmetric cryptography. If that key is compromised, the whole process is compromised. The whole encryption and decryption, the whole cryptography is going to compromise. There are some, whereas in asymmetric cryptography, there are this called public key cryptography, the modern cryptography, what we can say, where we are not using the same key for encryption and decryption, we are using different keys, so that the chances of being compromised are very less. Because just like you talk about your user ID and password of your, let's take my email ID and my password. So my email ID is my public. If you want to drop me a mail, you need my email ID. That is my public. But my password is my private. I cannot share my password with you. So if I want to open my mail, I need my public and the private key pair to open my email ID. So that is the private. But that the asymmetric approaches reduce the possibility of attacks to large extent. But again, the attackers try to do so many attacks, so many ways by which they can want to compromise this security out to some extent. So when I talk about, again, the symmetric cryptography, where we are using the same key for encryption and the same key for decryption, there are two major classifications which we normally know. That first one is transposition cipher, the premier, the older one algorithm which was used in 1970, near about that one, and substitution cipher. So if I talk about transposition cipher, one of the example is rail-fed cipher, a column transposition cipher. If I talk about substitution cipher, again, it is divided into two types: monoalphabetic and polyalphabetic. It is not being mentioned over here. But some of the prominent names I can give, like Vernan cipher, Wigner cipher, Playfair cipher. There are so many ciphers or algorithms which would become under classical cryptography, but we are not using these algorithms for the last 20-25 years because they are not secure anymore. But we are talking about the modern cryptography approaches, where we talk about stream cipher and block cipher. The stream cipher means they take the inputs of bits and they process one at a time. Block cipher means they can take multiple bits at a time and then they can process the whole block, which constitutes multiple bits at the same time. So that's why block ciphers process more amount of data as compared to stream cipher. But if I talk about some block ciphers like RSA algorithm, you talk about DES algorithm, data encryption standard, you talk about AES algorithm, advanced encryption standard. These are the algorithms which will come under block. And if I talk about stream cipher, it's RC4, RC5. So this is the normal picture of your cryptographic algorithm. Any one of your algorithms would come under this one classification, either symmetric or asymmetric algorithm. Because there are some challenges which are still there in these asymmetric algorithms, which are being taken care by the attackers, and they are compromising the applications which are using these symmetric algorithms, asymmetric algorithms. So let me talk about these very prominent cryptographic algorithms which we should know that The block cipher, I already told you that it's a block cipher. Sometimes we use a MAC, that is message authentication code, which is a very important concept for use for integrity, because some prominent algorithms under MAC are HMAC, CMAC, hash-based MAC, cipher-based MAC. There is another very prominent approach called Diffie-Hellman key exchange. Even I consider many times nowadays, I talk about with my students also, or with many researchers, they are still using Diffie-Hellman key exchange. Diffie-Hellman key exchange is one of the approach to exchange the keys between the sender and the receiver. And this approach, let me tell you, is a very good approach for exchanging the keys, where the chances of being compromised is very less. But there is one challenge in Diffie-Hellman that is called man-in-middle attack, MITM. Some of you might be aware about MITM, a man-in-middle attack, where attacker is just doing the impersonation. He's sitting in between the sender and the receiver, and he's just intercepting what is being communicated. What is being communicated between sender and receiver? He's going to listen what and all is being communicated. He's not showing his identity, because there are two kinds of category of attack, active and passive. So passive means their identity is not being shown. So similarly, we talk about Diffie-Hellman key exchange, which is one of the prominent algorithms, a key exchange approach, which is used for exchange of keys. How secure we can exchange the keys in a network. But nowadays, the persons are using elliptical key cryptography. Elliptical key cryptography is that approach which uses less computation and quite fast. And most of the papers, you will see the research papers, or when we talk about wireless sensor networks or ZigBee networks, where the energy is the main constraint. So here they are using elliptical curve cryptography, because that approach using less computation, less energy. That's why the system can run for a longer amount of time. One of the algorithms which is primarily used is RSA, which is the worldwide known algorithm, RSA algorithm, public key cryptography, but RSA is used in different variants also. And moreover, when I talk about another feature of which is required for security is authentication. How we can authenticate from where we are getting the data is the right person. If I'm receiving some mail from someone, whether it is coming from the right person or not, because nowadays you will see so many examples, like there are so many fake accounts which are created on Facebook, and the persons are demanding the money to the messages. And even the WhatsApp cloning is one of the common things, WhatsApp cloning. So how we can authenticate that from where we are receiving the information, or from where we are sending, we are getting the information, that is the trusted source. So we need one approach called digital signature. And digital signatures are primarily used for authentication. So there are two approaches primarily for digital signature. One is AlGamL and Snort. Still, these approaches are widely used. Even if I talk about my research, when I did my doctorate 5 years back, I used AlGamL approach for my authentication of the network, of the nodes which are lying in the network. So it doesn't mean these are the older approaches, but the way they can be utilized is more important. It is you have to decide that how we can properly utilize these applications, these algorithms in our various applications, in our various scenarios, or for these various challenges. So when I talk about the challenges in cryptography, there are network security, because both the things are going side by side. You need the cryptographic algorithm for the security of the communication, for securing the information. So what are the common challenges? I have given the source also for this particular challenges, which I have taken from techtarget.com. So what it signifies that correlating the security issue is one of the challenges. About 40-50% nearly says finding the security issues is one of the challenges. What are the threats? Verifying the threat, whether it's a threat or not. That is again 45% is a challenge. Because nowadays so many attacks are happening, and most of the time we are not even aware whether that our system is being compromised, because some new viruses, new worms, new Trojan holes, new ransomware, new kind of malware which are coming day by day. So it is very difficult most of the time to compromise, to understand what are the flows on this particular system. One of the challenges again here is to find the intruder, whether there is any anonymous activity which has entered to my network, or someone is entered to my network. So there are so many things which comes into the picture. But when I talk about when you work as a network, when you work as a team, these are the things which you should. What are the challenges? These are the challenges that we actually perceive. It is not about the industry. It is even we talk about if I'm working in a university. There's so many things which are happening. Even there's a chance that systems are being compromised most of the time. The applications are being compromised, and we are unaware. So whenever we talk about for the security purpose, we want that when we have some security, we should use some different ways by which we can secure the application. Like if I talk about email security, we must use two-factor authentication. But hardly many of us are not using two-factor or multi-factor authentication because it is a time-consuming process. But still, these are the things which are advisable, which can reduce the risk to a large extent. Now, when we talk about the threat, the possible threats which could be there for a network, it could be a physical theft. This is a very simple thing. You can just take the system from a particular location and there is a physical theft of there. But the major thing would be the program. Because now the attackers, what they are doing, they are sending some Trojan horse, some viruses, some worms, some keyloggers most of the time. These are the common source which is happening. Like some keyloggers are being there, and whatever the key you are pressing, that information is going to the attacker. And most of the time, these attacks are affecting your password of your credit cards or ATM cards most of the time. So there are different ways, and how these come to your system, to your network, because we are downloading some websites, we are downloading some applications which are not trusted ones, which are not coming from the trusted source. So we have to be very cautious. But these are the threats which are being there. There could be a threat like for hack control. Someone is entering to your network without it is not an authorized person. Like one of the common attacks, which is very prominent attack, is called DOS, denial of service. Where what the attacker is doing, they are sending huge amount of requests to the server, so that the server is not able to process even a single request. Because when the server is working on a concept of process management. Whenever the process request is coming, they have to provide the resources. It's called process management. But when multiple requests are coming, they have to process them in a particular fashion. But what the attacker is doing, they are sending thousands of requests. So it makes the server busy. And that's why sometimes we say that server is not responding or it is being breakdown of the server. It usually happens most of the time. So this is because of the denial of service attack. Or sometimes it is more devastating, like distributed denial of service, where the attack is not from one machine, it is from multiple machines at the same time. This could be buffer overflow, it could be brute force attack. And then when we talk about the brute force, it is the most successful attack. Although it takes time, but because with the high-end machines we are using right now, the attacks are possible. We are right now talking about quantum cryptography, quantum machines, which works with the quantum computing speed. So we need to devise some algorithms which have the tendency to overcome these quantum computing concepts. So that comes a picture called post-quantum cryptography, which I'm going to share very soon with you. This is a very prominent research area, post-quantum cryptography, that how we can overcome those quantum attacks because of high-end systems, high-end machines. So when we talk about these attacks, there are so many other attacks which are there. I was talking about CIA, because every organization would have CIA, confidentiality, integrity, and availability. These are the pillars for network security for any organization. So they must have these three things in their system. Then only we can say their system is foolproof, it is secure, the chances of being compromised are very less. So when I talk about a confidentiality, the most common thing for confidentiality would be like your snooping or traffic analysis. Because confidentiality means we are passing some information, and attacker main tendency is to read the information. So they are using some traffic analysis attack. Like, let me take one simple example. If you are aware about some tools like Wireshark. So Wireshark is used for traffic analysis. Like they can use to monitor the network traffic. And if you're using some unsecured websites, like which are not HTTPS secure, so even whatever the username and password you are using, so that can easily be even taken up by the attack if they're using Wireshark. So that is again one kind of attack which is there for confidential, because their tendency is to get the information what you are communicating to someone. There could be a number of attacks to integrity, like masquerading, if someone is pretending like someone else. Replaying attack means where the attacker is holding some resources, they are getting some information, they are making some changes in the data and then send the data to the receiver. And repudiation attack is there, modification is there. So these are the attacks which are related to integrity, means they are changing the content of that data. They are changing the content of the information. And if I talk about the availability, the most common attack is DOS, because availability means the user is able to access the services or the servers most of the time. But because of DOS attacks, denial of attacks, the services are uninterrupted. They are affected for a long amount of time. So these are the common attacks. And how we can overcome? First and the foremost thing is that first we have to see that whether my system is being compromised. Even though I applied the network security, I follow the principle. So there will be some glitch, some challenge, or some, you can say, some challenge from my end also that could lead to some attacks. So we should know that how we can to overcome these attacks and what could be the solutions and how cryptography will come into picture for taking care of these prominent attacks of network. So this slide will let you know about the most of the common attacks. I'm not going to cover in detail manner, but let me tell you, like when we talk about the common attacks of confidentiality, like man-in-the-middle attack or eavesdropping, like someone is listening to the conversation, what is going to be communicated. So we can use some symmetric encryption algorithm. We can use symmetric or asymmetric encryption algorithm because that makes my information secure. If I want to reduce this denial of service attack, or the main thing what we want is that the availability should be maintained, then we must use digital signature. So I told you that for digital signature, there are so many different algorithms in cryptography, like algamel, node. You can search these algorithms, you can explore these algorithms. There's one called RSA digital signature, there's called DSS, digital signature standard algorithms, which are prominently used for digital signature. For traffic analysis, we can use some secure traffic patterns, we can use some special keys, we can use some flags during communication. Like for brute force, we have to make some strong encryption algorithm so that it would be difficult for someone to compromise that algorithm. Because how brute force will do, they will try all possible combinations of all the numbers, special characters, all the alphabet. But if I use some complex ways by which this algorithm is doing the encryption, then definitely the chances of brute force can be reduced to some extent, to larger extent, I would say, because it will take huge amount of time to compromise that algorithm. So, but one thing which I need to notice that here, one of the prominent attack is cyber attack, which is a very, very prominent attack. The persons who are working in networking field, they know about this particular attack where attacker is creating a multiple node, means a multiple identities of a particular node are created in the network. And this is the most common attack, a cyber attack, where you have to find a clone, you have to do the clone detection. So that is also very important. And here you have to use some certifying authorities or certificate validation procedures to mitigate this particular attack. So whenever we talk about any attacks in networks or in terms of network security, we know that these are the resources, these are the features, these are the requirements for a particular network like CIA or authentication and other things. We must apply the algorithms in a right, appropriate manner. And cryptography helps a lot in securing those or to overcome those challenges of some attacks, which I have already told you. Now, there are some very important solutions, or I would say these are the challenges which are still not being resolved very effectively, and still there is a scope to work upon these challenges in the time to come. So when we talk about the cryptography, whenever the two devices are communicating, they have to share the key, because key is either public or private. Even though they can use Diffie-Hellman key exchange for sharing the keys in a secure channel, but that is also secure. I told you there is an attack called man-in-the-middle attack. So establishing the key establishment is again a challenge. Even you can use random key. Some of you would say yes, we can use random key. We can share some shared key in the beginning, but again there is a chance whenever you share the key, there is again a challenge that if that system is being compromised before that, then how you will overcome this? So key establishment is again still an open challenge which can be worked upon. Again, authentication and security is again a challenge, because we want end-to-end cryptography, we want end-to-end security from center to receive. But to maintain the end-to-end security, we need high computation algorithm, we need high computation machine. And when you use some advanced algorithms or very complex algorithms, definitely they need more resources. They need more bandwidth, they need more resources. So definitely you cannot deploy those algorithms in some scenarios where the cost or energy is a limitation. Let's take a very simple example of habit cat monitoring. Let's take one example, like we place some sensor nodes in some areas, like to monitor the movement of animals in a bird-like sanctuary. You cannot, a person cannot go over there and count the number of animals. You have to place some sensors over there, which can collect the data, sense the data, and send to the base station. But that sensor node has some limited power. If you apply some algorithms, which are complex ones, even though you want to add the security, you want to apply some algorithm which are complex one, do you think that they will go for a long amount of time? No, they will not go for a long amount of time. That is again a challenge. Because these all things need to be taken care of whenever we are devising the algorithm. When we are applying the algorithm for a particular application, we must know that what kind of application that is. Then only you can finalize a particular algorithm for that application. Again, when we talk about the DOS attack, which is a denial of service attack, which is a very common attack, we can go with text spectrum communication, means we can apply a frequency of different frequency. So there is always the challenge can be reduced. But again, deploying the text spectrum communication or text spectrum techniques in cryptography is again a very common challenge. It's a very big challenge, I would say. Secure routing, because when we part of a network, we always want that the data should go from one end to another end in a different way, and that comes the routing. Routing is finding the best path. So sometimes what attackers will do, they will create a fake path, or you can say a wrong path, and once the package will take that path, it will never reach the destination. There's some kind of attacks like wormhole attacks, black hole attacks. These are some common attacks which are because of routing attacks. When I talk about routing attacks, so that is again one area of concern, that how we can overcome these routing attacks in terms of network, so that the packet can reach the destination in a secure way. Again, there is a challenge called IDS, intrusion detection. How we can detect the intrusion? We have threat models are there. So many models are there that we can detect the threat. But again, modeling is again a big challenge. How to design those applications? How to design the threat model? That is again a challenge. Last but not the least, I would say the secure data aggregation. Whenever the data, because whenever we send the data, there is one particular node which receives the data, and that will broadcast the data to others. So how to find the location of that node to be secure? Like when we take a simple example of banking system, the bank server, they need to be secure. If that bank server is being compromised, that, then we can imagine that the whole funds of the persons or the common people will be compromised. So the banking officials or the banking, they are not storing the data on a single server. They are doing the mirroring. They are taking the help of some organization like SAN. They are using storage area network device, SAN device. They are taking help of some companies like EMQ Sphere, which helps them to store their data in some different locations. Because the data is not stored at one server, it is stored in multiple servers. So in case of failure of one server, the data can be recovered or from a different server. So again, the most important challenge today is securing the location of the server, getting the location of the data source. That is one of the important challenges. Or we can say localization. How we can secure the localization? Because localization is finding the location of a node, location of a source. So how we can do? So that is again one of the important challenges, and still there is a huge scope to work upon in this particular direction. Let me talk you, in the beginning I was discussing like, when I talk about the network is not only a simple network we use a wireless network. Network is much beyond that. Sometimes we call as a MANET, mobile ad hoc network. Like our mobile phone, we are using mobile phone. We are not fixed. We are moving with the mobile phone from one place to another place. So this is a MANET. There is not a physical infrastructure. It's a connectionless infrastructure. Okay, we are moving from one end. We are multi-hopping. We are moving from one end to another end. And again, when we talk about the MANET, there are so many challenges, so many issues. One of the most important issues is the mobility, because here the node is not fixed. Here the location of the mobile phone is not fixed. It is changing. So mobility is again a challenge, because with the mobility, the position of the node is also changed. So there's so many things which comes into picture again. The wireless medium is again a challenge, because we talk about the two mediums, wired or wireless, and we know wireless is not as much secure. Even though we know that we apply some good algorithms, good cryptographic approach like AES, WPA. But still, I take example like even your WPA2 approach, WPA2, which is the prominent cryptography security algorithm used in your wireless hotspot or wireless communication. It is also being compromised 4 years back. So again, still we are using WPA. Now, these are the common things which are very important. We should work upon. So the thing is very wide. The area is quite wide that we can explore as much we can in terms of computer networks, in terms of your network. So this is always a challenge. Again, if I talk about the one prominent thing which is there right now is cloud computing. Everyone know about the cloud, Amazon cloud. We know about the cloud computing where the data is being taken, is hosted. We are using the cloud services because we are paying as much services we are using. We don't need to procure the services at one instance. So we're using cloud computing, and there are so many you can say types of cloud like public cloud, private cloud, hybrid cloud, community cloud. There's so many things are there. So when we deploy a cloud, there's so many issues which comes into picture. Issues related to security, issues related to deployment. But here we are talking about the issues related to security because our topic is research paradigm with network security and cryptography. So first and the foremost issue is the infrastructure security. How you can secure the infrastructure, how you can secure the cloud services. Because cloud service providers are providing you the services, but how your infrastructure will be secure by the cloud service provider, how the data would be secure, how the data would be stored efficiently. That is again a challenge. Another thing which you might be knowing about cloud and cloud computing is migration, VM migration, virtual machine migration. We are moving the data from VM to physical machine so that the data can be efficiently used. There is scalability, there is durability of data, energy efficiency is reduced, the performance can be enhanced. There are so many things which we want for during the VM migration techniques. There are two types, live migration and static migration, which is very much advancing. But there is a challenge in VM migration also. And we are migrating the services from one cloud service provider to another cloud service provider. So again, that will be a challenge. Identity management, who's going to access the cloud, whether that one is the right person or what the kind of access we can give. That is again a challenge which we need to work upon. And privacy. So whatever the resources you want, so that will be secure. You have the full control over the resources. No third person can get a hold of those resources. They know what you are searching upon. So these are the things which we must know that these things can be, I would say, can be done to a larger extent in terms of cloud computing, where there is a scope of improvement. And these are the things which I have taken, like when I explore, these are the latest research things which I mentioned over here, research areas for the futuristic approach, like post-quantum cryptography. I told you that with the speed of quantum computing, the systems are having high computation power. And with this high computation power, definitely any algorithm can be compromised. So must devise some algorithm. There is a need of some algorithms or some cryptographic approaches which have the potential so that we can restrain to a larger extent. Okay. So this is one paper which I've taken from just a latest paper from March 2010. There is sensors, a very renowned journal for MPPI sensors. So what it says that we talk about the 6G technology, right? We talk about how to use the quantum cryptography in 6G technology. Most of us, we are knowing about 5G, but 6G is also in the picture. 6G is more fast and more, you can say, compatible, but still there are some issues pertaining to the security in 6G. So what kind of quantum, how this computing, how this cryptography would come into play to secure your 6G communication, which will be the part in the next 4 to 5 years. So in this scenario, I would say that quantum cryptography or post-quantum cryptography will be one of the solutions, which could be there as a future area for everyone to work upon. If someone wants to work in cryptography, then post-quantum cryptography could be one of the open areas. So here there are so many cryptography techniques like lattice-based cryptography, code-based cryptography, multivariate cryptography techniques are there, and hash-based signatures are there. These are the latest technologies, latest cryptographic approaches, which are primarily used in today's scenario. If I talk about multivariate cryptography, we talk about rainbow signature. We don't talk about this signature, we talk about rainbow signature. If I talk about quantum cryptography, we use anti-RE algorithms in case of lattice-based cryptography. So when we talk about the cryptography, there are so many other things which comes into picture in post-quantum cryptography. We will talk about integer factorization problem. We talk about logarithmic problem. We talk about elliptical curve, logarithmic problems. There are so many problems which make or the things which you have to going to use in these latest cryptographic approaches. And these are the approaches, let me tell you, these are the approaches of the future, where the cryptography is going to be utilized in the various applications. The second thing, which could be a very vast area for future work, would be the IoT security. Because when we talk about IoT devices, Internet of Things, where all the devices are connected to one another, the interoperability is one of the issues, that how they will going to communicate with one another, how the information is going to be exchanged. So whenever we are going to devise some solution, some security solution, we have to provide a holistic security solution. Holistic means that is going to cater all the needs of the particular system or a particular network. So there is a need of development of some threat analytics, risk management as well, because these things are not being covered. We covered a lot of more about securing the data, but we have given a less stress or less, you can say, a stress or less inputs about the threat analytics. That's what kind of threats which are there. What is the behavior of those threats? How the risk? What is the possibility of whether the risk factors are there, and how we can mitigate those risks? So that could also be the part of the IoT security. So there is a need of development of holistic approaches which take into account of threat analytics and risk management in the various applications which are going to be designed or developed in the future in IoT security. Another very important category of cryptography when we talk about is your homographic cryptography. So homographic cryptography is the latest thing. We know that cryptography means we take the data, we put some into algorithm, we get encrypted data. And at the receiver end, they apply the key, they get the decrypted data. But again, there is another thing which comes into picture, is called homographic encryption. It's a very latest technology, homographic encryption. This is a different category called full homographic, partial homographic. So what they are actually doing, they are just applying some asymmetric public key cryptography on those algorithms. We are not applying any algorithm. We are just encrypting the encrypted data. Whatever the data which is encrypted, we again encrypted the data. We again applied encryption with a simple way, with a simple symmetric algorithm. So just what we are doing, we are not revealing the original message. The original information is not being revealed to someone who is going to decrypt it, the data, who is going to do the cryptanalysis. So this is called a homographic encryption. And one of the important things, just one slide is more like a blockchain. Everyone is aware of the blockchain. We talk about blockchain, we simply know that blockchain is somehow cryptocurrency, but it's more than cryptocurrency, it's more than Bitcoin. Bitcoin is basically a cryptocurrency which is based on the concept of blockchain. This is the concept of decentralization of the hashing. But blockchain is much beyond that. You can use some blockchain to make some trust model to make your system more secure. Even I have done 5 or 6 publications of blockchain where we have used the smart contracts to do the blockchain implementation in farming also, in UAV also, there is unmanned area vehicles, or in some other scenarios also, in medical scenarios also. So there's so many applications of blockchain. We can develop some smart contracts. We can use some hash algorithm. We can use some hashing or some other ways. We can implement your own hyperledger or some other tools. Solidity language can be used to create smart contracts. So still, I would say a blockchain could be one of the possible solutions for the future for securing, for trust management, for security. And that can be explored a lot. That can be used a lot. But one of the challenges which is still there, which can be worked upon, is creating the lightweight blockchain-based technology. Because blockchain technologies require more bandwidth, more resources. And you know, resources are always a constraint. So developing a blockchain solution with less constraint environment, with the lightweight, with less requirement is one of the futuristic approach which can do that. So some of the research areas which I'm giving you as a last one option, like which you can work on secure source layer architect design. You can work on some privacy and security solutions for wireless communication. Design and development of ultra efficiency security models which require less energy. Security of the cloud is a very open area. Threat prediction means insider threat prediction. In that you have to predict what is the possible threat in your network. If your network is still secure or is being compromised, and it's always a challenge because many of us are not knowing that my system is compromised, my network is already compromised. So inside threat detection is one of the very common challenges. one of the very, you can say, open area of futuristic approach, which we can work in the future. So with this, I am ending my presentation, but let me tell you that there are so many other things which could be there in cryptography and network security. It's a very wide open thing, and you have to explore. And for this, you have to very much clear that what the basics should be very much clear. Then only we know that what are the challenges and how we can overcome those challenges by the technologies that we have discussed today. So if you have any concern, you can reach me through LinkedIn or through my email ID. And if we need any collaboration in the future, also like we can work into projects. Even I was looking some of the projects of done by University here of Pennsylvania. Like you're working on this one, a side channel attack. I was looking for that one out. So that is a very good marvelous work, because there is a cryptographic research lab is also there in the university. So again, that could be explored a lot, because there's various ways by which the side channel attacks can be overcome to larger extent, using deep learning based approaches, using timing based approaches, using some countermeasures like blinding, masking, some other ways by which we can reduce to some extent the side channel attacks. So thank you so much for your time. Thank you.
Thank you, sir. We are grateful for the time and effort you took to share your thoughts and experience with us. Let's move on to questions and answers. To resolve any questions regarding today's seminar or any question related to network security and cryptography, I believe our speaker is now ready to answer questions from the audience. You may leave a message on the Zoom chat or unmute your mic and speak. Meanwhile, you can still question on the Zoom chat and you may...
I think they can ask the question, even I will respond to the question also. You can share those questions with me to the chat. I will respond to each and every question.
Yes, sir. We have some questions in our Padlet form. May I ask those questions from you, sir?
Sure, you can ask.
The first question is, are there enough research opportunities globally for someone who is willing to do a higher degree in network security?
Definitely, there is so many opportunities. If someone wants to do for higher education, one of the prominent areas you can work is in cybersecurity, because cybersecurity is one of the prominent areas which needs the ideas, the concept of network security also. So there are so many openings of cybersecurity across the globe. If I talk about in Canada also, there is the University of Brunswick, which is offering a program of Masters of Cybersecurity, and the applications are just open now for the winter fall. Where the AT&Bell, that is AT Bell Laboratories of, that is very right name, AT Bell Laboratories, is sponsoring those candidates. So they're sponsoring 30 candidates every year, AT Bell, for MS degree program, master degree program, for someone who wants to do masters from University of Brunswick. So they're offering specialized programs in network security, cyber security. So there's ample number of opportunities in India also, in Canada, in Australia, in America, everywhere.
Thank you very much, sir. The second question is how social engineering affects network security, and there is any safety measures.
Social engineering is a totally different way. Like social engineering use is sometimes way that by different ways, by communication. We want to get some information from someone. Like there's also shoulder surfing sometimes also. We want to see that what kind of information, what kind of password my friend is there in communication, or by looking from the backside also. So that is the social engineering. But definitely, social engineering can affect the network security to larger extent, but that is not as much, you can say, devastating, just like the other potential attacks that I have described in my presentation. So they are more devastating. Social engineering, you can keep it with your most, you can say, more involvement, or if you are more, you can say, very much cautious, then it can be avoided to larger extent. But other attacks are very difficult to, you can say, mitigate or able to find out.
Sure. third question is, what do universities, research institutes typically look for when they pick candidates for a PhD program in network security and related areas?
Okay. So when I talk about if someone wants to go for a higher PhD program in network security and cryptography, there are 2 or 3 things which you should know. The first thing is that your basics should be very much clear. At least you should know the basics of cryptography and network security. I've just given you some of the glimpse today in my presentation. And most important thing, what you need to do is that you should have some at least 1 or 2 good publications. I'm talking about a scenario if you want to apply some foreign universities of good repute, like top 500 times higher education university across the globe. So you must have some 1 or 2 good publications, good journals, some reputed journals. And apart from that, if you have some projects in collaboration with someone or some patents also, any patent filed or any patent granted, so that would add an advantage to that one. But at least your concept should be very much clear. And second thing, 1 or 2 good publications of either in journal or conferences, that will add advantage to you to get a good job position or a good offering for a PhD program in a good institute.
Thank you very much. The next question is, if we compare the integrity between cloud deployment models and traditional deployment models, does new cloud models provide more security than the traditional?
Yeah, definitely. The integrated cloud models are providing more security as compared to traditional models because of the technology they are using. If I talk about cloud computing, one of the technologies called multi-technology gateway management. And this is the latest technology which is happening where we are integrating multiple devices of various nature in the cloud environment. So security of this is very much important one, and definitely the integrated cloud computing is more secure as compared to traditional one because there is always the challenge of you can say security breach or confidentiality issues or some other issues which are still in the traditional models, which are taken care to larger extent in the latest models of cloud computing.
Thank you very much, sir. The next question is, what kind of educational background certifications required to step into the industry in cybersecurity?
Let's talk about cybersecurity. I'm from this particular field of cybersecurity. As you mentioned during the presentation, I'm CompTIA Network Plus certified security engineer. I am EC Council Secure Computer User CSU. I am CCNA certified. So these are the things which help you to a lot, not in the education, in the industry also. There is a huge amount of certification in the global certification in the industry. If I talk about if you want to make your career in network security, you can go with CCNA. That is Cisco Certified Network Apprentice is a known certification by Cisco. You can go then with CCNP, with CCIE, which is advanced form. You can, if you want to go to cybersecurity, you start with the CEH, Certified Ethical Hacking, which is a most prominent global certification. You can go with CompTIA Network Plus, CompTIA Security Plus, CompTIA Apprentice Plus. There's a number of certifications by CompTIA also. There is a one very known certification called SANS. You know what SANS is, a very known organization for security. There is OVATA also. So there are a number of opportunities are there. If you have 1 or 2 good certifications, then definitely you will be the first candidate right choice for any organization across the globe. If you have 1 or 2 good global certifications. And even you can try for Juniper also. Juniper is also providing some certification in cloud or in networking also. That is called GNCP or GOIUS, GCI. So the candidates who want to go for certification, they can explore these certifications. And they must at least do 1 or 2 global certification in their career, so they can be industry driven or they can be industry leader, ready for the good placement in the future.
Thank you, sir. The next question is, what is the role of machine learning in future of cybersecurity?
Listen, one thing, when we talk about cybersecurity, we talk about the various how we can secure our communication. We talk about what kind of possible attacks which are happening in the network or in the cyber world. So machine learning, you know, when machine learning is basically the intelligence. We are making that system, we are making an application with so much intelligence that they can take the decision by their own. So when we talk about machine learning, there are ample opportunities of working on supervised and unsupervised machine learning algorithms. And nowadays, we are applying the machine learning in malware analysis. Malware analysis is a very renowned, very new thing which is happening in cybersecurity. We are analyzing the malware, finding the definition. So here comes the role of machine learning. the malware is of two types, static and dynamic malware analysis. And we are using some techniques of machine learning for the classification of malware. We use PCA, principal component analysis, sometimes use fourth sector machines. Now we are using ensemble approaches like bagging, boosting, random forest. There are so many decision trees. These are used for classification of malware. So machine learning is used nowadays for classification of various malwares in cybersecurity.
Sure, sir. Those are the Padlet questions we have got from the audience, and we thank you for your questions. And once again, Dr. Prashad, thank you for spending time with us today. Also, we would like to have your feedback for make our future seminars more successful. Please take some time to fill out the following survey we have shared in the chat. And so that brings us to the end of today's informative seminar. And thank you for all being here with us today. Until next time, I wish you all a pleasant night. Thank you very much.
Thank you, Harshan, and everyone being the part of the presentation. And I hope that you all explore and you all research in these paradigms of network security program. Thank you, everyone. Have a nice time.
Thank you very much, sir.
Thank you.